Last for our morning session, we have Birgitta Malm Renöfält from Umeå University in Sweden, and she's going to talk to us about Sweden's bypass rivers and restoration.
So obviously Roland Jansson was supposed to hold this presentation. Unfortunately, he couldn't come, so he sent me this presentation and said, give it. So I will do my best. It's always difficult to get into someone else's head what they thought about it. But I will talk about the project that we have done together with a lot of people where we have mapped values and ecological rehabilitation potential of bypassed reaches in Sweden. So this is a repetition from the picture from Åsa about loss of riverine ecosystems in Sweden. And these are focusing on reaches with higher flow velocity, like rapids, waterfalls, and runs, and riparian ecosystems. And in the first picture there, you can see Harsprånget up in Luleå River before and after regulation. And as also said, this is the case in many of the large developed rivers in Sweden, that we only have a fragment of those kind of reaches left. And in the lower picture, you can see riparian vegetation in the free-flowing Vindel River. And in the other picture, you have the riparian vegetation in the nearby Umeå River, where it's heavily, in the first picture, you can see this wide riparian zone with different types of vegetation depending on flooding time and so on. And in the second picture, you have a heavily eroded riparian zone with the upland encroaching and eroding due to hydro peaking. And it's the same there, that this is a very common loss in regulated rivers. So what is the fate of those rapids and waterfalls? Well, many are dammed over as we develop the river, so they are dammed over in reservoirs where we have risen the water levels, and they are now under flat water levels. And others situated at hydropower station are bypassed, where they have either the entirety of their flow diverted or parts of their flow diverted. And oftentimes modified also because they're used as spillways in case of emergency spills, etc. So they're often also blasted and their morphology is changed. And if you look at the right-hand picture there, this is the development scheme of the Umeå River. You can see there is a tributary and a hydropower station called Storjuktan, where 88% of the water is led to an underground hydropower station and out in the main stem of the river. And Jukton, which I will come back to, has 12% of its flow left. But I will come back and talk about that. So in this project, we inherited a database from the Swedish Hydrological and Meteorological Institute, where they have started mapping these bypassed reaches in Sweden. And we expanded on that. We added reaches. We also added information about the reaches, the length, whether there were tributaries coming into it, whether there were minimum flows, whether we had any data from electrofishing, invertebrate data, and so on. So we have added a lot. We have also added reference reaches to be able to use in comparisons for that. And we found that we have 964 bypassed reaches in Sweden that are longer than 30 meters. There are also additional that are shorter, but we have omitted them. And 800 rapids are laid dry. The mean length of these are 1,319 meters, and the median length is 390 meters. And the absolute majority of them lacks minimum discharge, so 73% has no minimum discharge. And for those that has minimum discharge, the mean is about 8.3%. And you can see in the graph that most of them have have actually not that much water in them. And they are not randomly distributed in the watershed, but most of them are positioned close to the mouth. So this graph here shows a stream order counted from mouth. So one is actually at the end of the river, so to speak, opposed to free-flowing reaches in those rivers, which are often above the highest dam. And we took the sub-sample of those reaches that had electrofishing data and compared to our references. And what we saw was that rheophilic dominance, that is dominant of species that likes high flow velocity, like grayling and brown trout, was significantly lower in the bypass reaches compared to the references. And also fish abundance, the total number of individuals of fish, was lower compared to them. But fish species richness was actually higher in the bypass reaches due to species that like more lentic environment, like pike and perch and so on. But the good thing was that we also looked at what is the effect of actually letting some water into those reaches. And we found that with a relative modest amount of water, and you should note that this is absolute discharge, so this is cubic meter per second, we actually get more rheophilic fish in. So when we reach about 2 cubic meters per second, that actually does something. But I should mention a caveat here that most of those reaches are, of course, smaller to medium size. So we don't have Harsprånget here, for example, because they're dry. So with this, I won't say that 2 cubic meters would do wonders in those kind of big rapids, but at least it's interesting to see that we relatively fast reach a point where we get more rheophilic dominance, more close to what the mean in the reference are, and we don't get a lot of extra value with the extra water, so that's kind of interesting. And another thing that we saw was that it's also really good to have a good riparian zone with tree cover that provides shading and so on for the proportion of rheophilic fishes in. So different aspects of flow needed to support different ecological and hydromorphic functions. Well, obviously, if you just want water, some kind of aquatic habitat, then you need less water. You get a wetted channel, but you don't really, and this is often the case now, you have very little water left in those channels, maybe for aesthetic reasons. You have built weirs to keep up appearance of more water, but what is that water doing in the system? You don't really create these lotic environments. So in order to do that, you need to maintain some minimum flow velocity in the river and maybe provide a little bit more water, obviously, and also think about whether you build those weirs or not and what they do to your water velocity. If you want to provide more diversity in habitat, more diversity in velocity, in depth, and so on, a different kind of hydraulic conditions, to increase species richness or provide refugia, for example, during warm periods and low flows, you probably need more discharged. If you want to support the riparian zone, you won't need to do that either by providing a high flow, or if you have the possibility, like I will talk more about tomorrow, if you have like dams in both end of a reach where you can actually mimic high flows, you can do that. So providing water for the riparian zone doesn't need to mean that you provide more water. You can provide higher water levels, so to speak. But it's not in all cases you can do this. But yeah, to maintain those land-water interactions. If you need to actually, if you want to create and rejuvenate habitat, for example, if you have a longer bypass reach that is valuable to you, then you also need to provide those flows with enough energy to start moving around things, of course. And I will talk a little bit about a project that we are working with in that part where I showed you, Jukton, in the Umeå River catchment. So this is a really long bypass reach. It's 68 kilometers long. It's definitely the longest in Sweden, possibly in Europe. It has 12% of its mean annual discharge left, and it had a lot of weirs to rise the water level in the river. So basically you had a situation where you had areas where you had very slow flowing water, and then you have weir, and then you had very turbulent water, and then weir and slow flowing and so on. So it was quite morphologically quite unnatural conditions, and it's also like most rivers in Sweden been used for timber floating. So there had been some restoration done after that, but we also needed to do extra restoration due to the effect of channelization from timber floating and so on. The minimum flow, it had a minimum flow, as I said, but it was very static. 3 cubic meters in winter and 5 cubic meters in summer, and then a little peak of 6 cubic meters very early in the year. We think it might have been to break up the ice. We're not exactly sure why it had that. But anyway, from 2021, the minimum flow wasn't increased. It's still 12%, but it was changed to mimic more of a seasonal flow variation. And also the timing when that is, it's not fixed in time when it should be. You have a window to match it to when the snow melt is in the surroundings. So you get that, matching and the extra water from the local runoff and so on. And apart from that, so we have a project now ongoing where we will study the effect of this. And the whole Jukton, the upper part of it's totally free flowing. And below the big reservoir where the water is taken out, that part is only hydrologically restorated. And the lower part of it's both hydrology and morphology. So we have quite an interesting system now that we look into. What are the effects of different things? So that is also a project that we have started, and we will work on more this summer. So this is before morphological restoration. You can see a typical weir here. And after restoration, the channel was adapted to this seasonal flow, and also adapted to, because this is used sometimes as a spillway as well. It has to be able to harbor maybe 100 cubic meters at the time. So give room in the river for flooding as well. So you can see here that the weirs are removed and flattened out to improve water velocity. It was also important to keep a deep thalweg, so you have water at low flows all the time, and provide room for flooding for the river. And vegetation, we looked also, we will follow up because we've done a lot of inventories before measures were taken. So we inventoried riparian vegetation, aquatic vegetation, done electrofishing, sediment and movements and so on. And we have also done projected responses of the riparian vegetation. So the riparian plants in an unregulated natural northern river is very much zoned after flooding times. So in the lower part, you have those plants that can stand a long flowing time. And in the upper part, you only have riparian forests that can stand shorter floodings, and the graminoid and the willow zone in between. And in the lower part here, you have probability curves of different species where they occur depending on where they are positioned in the riparian zone. So based on flooding times, we can calculate where different kind of vegetation will be. And this is before and after restoration in Jukton. So before, hydrologically, we only have, because it's very static, we only have the amphibious vegetation. But after restoration, we will get some, not a lot, but more of the graminoid and willow and riparian zone shrubs. So this is just models of what will come in part of the river. This I will talk about more tomorrow. It's from another bypass reach down in Dalälven, where we also want to provide floods for riparian areas. So to sum this up, when we work with this rehabilitation of bypass reaches, it's really important to identify the targets and goals and what are the reference conditions. The målbild we heard about yesterday, what is that? Where would you want to come? But also map the natural values that in there through field inventories and describe what are the current conditions. So what are the environmental impacts? What are the habitats we are lacking? What are the natural values that are there? And also, is this bypass reach possible to use for connectivity, increasing connectivity in the watershed? And identify the needs for ecological rehabilitation to make, and then you make the list of where you want to come, what are the reference conditions, and based on the scope of that rehabilitation, based on the costs and based on the impact of hydropower production, you make your prioritization. That's a really hard word to say. So to sum up in conclusion, rapids and waterfalls has been lost to a very high degree as a result of regulation. And most of those reaches doesn't have any mandated minimum discharge. They're primarily located in the lower part of the systems, and only relatively modest minimum flows can bring back rheophilic fish fauna. And if you want to maybe you want to introduce seasonal variation in flow, for example, you can get back some riparian vegetation and so on. And you need to do this systematically to identify the potential and see what you can get throughout Sweden and then make your prioritization, because I think it's a great scope we need those kind of reaches back because we lack them. And this is Roland, who was supposed to be here and talk. He was the project leader of this project. Also Åsa, as you've met here. And a lot of other people have been involved in this project. Thank you.